All right. How you doing? Are you good? So, listen to me. Do you like math? Respond. Wait, what did you say? I just want to be certain, right? Like this lady in the middle, she's asking, "Wait, what?" Okay? Now, but this lady over here says, "No, no, I don't like math. No, I don't like math." But the lady in the middle said, so, probably." But the man over here said, "Totally, totes, I like math." See? You could express it in words, but guess what? We can express how certain we are by using numbers. A fraction, a decimal, or a percent will tell you how certain you are. And that's what we're going to learn today. We're going to learn about probability. Here we go. Let's start with definition of terms. A sample space is associated with a random experiment. It is the set of all possible outcomes. You made an experiment, all the results that came out is called the sample space. This is what came out. Now, the event is the subset of the sample space. So these are all the possible outcomes, but now, check this out. This is what I want. I want to get a group of three. That's an event, right? And the outcome now is the possible result of an experiment. What came out is called the outcome. All right? You will understand this fully through our examples. Now, let's start with the definition of probability. It is the measure of the likelihood of an event or outcome. It is the chance of something to happen. We want to know the chance. The probability is all about certainty, uncertainty, or sometimes you use it to predict something. Yeah. And what else? Some events are impossible. No way, that's not going to happen. Sometimes are certain to occur. Yes, it will happen. But sometimes it's in the middle, possible but not certain to occur. What else? It appears as a number. Okay, it's not written in words, it's a number. It's a ratio fraction, a decimal, or a percent. For example, you could say the probability of getting a result of 100 is 1 half. Or you could say zero point 0.5. Or you could say 50%. This number tells you, it's in the middle. Okay, so let's start with the probability formula. Remember this formula, okay? The probability of an event denoted as PE. You will see this all the time. P means probability. E is the event, what you want to happen. Is the likelihood of that event occurring. The probability of an event, this is how you write it, P parenthesis of what event, is the number of ways it can happen, what you want to happen, okay, over the number of possible outcomes, writing down all. This is like the part, this is the whole, okay, remember that. Now, example, what is the probability of getting an even number when you throw a dice? This one, you throw it once, okay. So how do I write that? Again, you will write the P stands for probability of the event. What do we want to happen? Getting an even number. All right, so write down the word even number. Even number. Okay. Probability, how do you read that? Probability of getting an even number is equal to a fraction. How do I write that? Okay, now, possible outcomes. Okay, now this is now called the sample space. The possible results are what? 1, 2, 3, 4, 5, and 6. Do you agree? Yes, that will be the results. And how many are they? A total of what? 6. So that goes at the bottom. There you go. The total, that's the whole. Now, the part that I want to get is what? All the even numbers. So let me use my blue ink. The even numbers are 2, 4, and 6. How many are these? Okay, the event that I want to happen could be 3. So I put 3 on top. So that's it. The probability of getting an even number is 3 over 6. You can simplify that as 1 half. Whoa, you know your ratio, okay? That could be written as zero point 0.5. You could also write that as what? 50% chance, okay? So is it in the, are you certain or uncertain? It's in the middle, right? Okay, half and half. So that's the probability. Got it? Next, we have to look at the probability scale. What is a probability? You this one. Check this out. Okay, so certain, if you're very sure, the probability is 1. Like the sun is rising, right? If you are not certain, like impossible, never it will happen, rolling an 8 in a dice, definitely that will not happen. So the scale is always 0. Take note, 0 up to 1. 1 represents certain, very sure. 0, no way. But of course, in the middle is your even chance. Okay, for example, when you toss a coin, it could be heads or tails. The chance are equal, right? So 50% chance. Okay, if you're on the upper part between those two, you could say very likely or likely. Okay, the more you go to 1, the increasing likelihood it could happen, right? And then the one between the impossible and the even chance, you could say not likely, or you could say unlikely. Okay, so remember, the scale is always from 0 to 1. You cannot go beyond 1. You cannot go lower than 0. Okay, let's try this problem. For this experiment, we have a bag containing 10 cards. Here are the 10 cards. Each card is numbered differently from 1 through 10. And each trial, we reach into the bag and pull out exactly one card. We look at it and then return it later for the next problem. Okay, let's start with the first problem. What is the probability of getting a 7? Okay, again, write the P and then parenthesis event. I want to get an event of 7. All right. So the bottom, how many chances? There are 10 chances below. I don't need to count that. You're looking here. And where is 7? 7 is over there. How many 7s do you see? Just one. So you write 1 out of 10. The probability of getting a 7 is 1/10, or you could write 0.1. Okay, got it? So it's less likely, right? Towards to almost not uh, getting a 7, but very unlikely. Okay, number 2. What is the probability of choosing an even number? Okay, let's erase this 7. Let's now circle the even number 2, 4, 6, 8, and 10. How many even numbers do I get? 1, 2, 3, 4, 5. So the probability of getting an even is 5 over a total of 10, or you could say 1/2. So what can you say? Even chances, right? Even chance. You can get it or not get it. 50-50% chance. Okay, that's clear. All right, let's try another one. Okay, number 3. What is the probability of choosing a card numbered 1 through 10? All right. So probability of getting any card from 1 through 10. Parenthesis, the total chances are 10. So how many 1 through 10 can you get? All of it. All right? So are you very sure? Yes, 10 over 10 or 1 whole. You are certain. You are very sure that when you pick a number, it's a number from 1 to 10. Right? 1 is certain. Remember, 1 is certain. Okay, let's try the last one. Let's erase this. What is the probability of choosing a number 12? Look at our choices here. Can you see a 12? All right, probability of getting a 12. No way, there's no 12. So 0 out of a total of 10. So 0 divided by 10 is 0. So what are the chances? No chances. You are very certain that it will not happen. Okay? Good. Next. Another vocabulary is complement. Okay, if I tell you that my wife complements me, my wife completes me, whatever I have and whatever she has, put them together, it's complete. Complement. Got that? All right. So let's read the definition. It is the sum of the probability of an event happening, and the probability of the event not happening, not happening, add them up together, it's always equal to 1. Whoa, are you sure? Okay, let's check this one. When you throw a dice, what is the probability of getting a 6? Obviously, how many 6 do we have? There's only one 6. Out of a total of 6. Okay, 1 6. Probability of getting not 6. Not 6. So, if it's not 6, it could be 1, 1, 2, 3, 4, 5. But not 6. So, how many is that? I can choose 5. Favorable is 5 out of a total of 6. Okay. This one is 1 6. The other one is not 1 6. The opposite. Guess what? If I add this probability and that probability, what do I get? 6 over 6 or 1. All right. So probability of 6 complements probability not getting a 6, and probability of not getting a 6 complements the probability of getting a 6. Put them together, it's always equal to 1. Next, let's apply that. Okay, so if the probability of raining today is 2/5, raining is 2/5. The probability of not raining. Okay, so let's write it down. So remember, probability of raining plus a certain probability should be equal to 1. How can I make that equal to 1? So not raining would be, okay, to make that 1, it has to be a 5. And what number could this be? To make it 5 also? 3. Yes, because if you add these two fractions, it's going to be what? 5 over 5, which is equal to 1. Okay, which has more probability of raining or not raining? More probability for not raining because it's bigger. But if you add them, it's always equal to 1. Remember that. Next, the probability of getting a perfect score in math is 7/10. Yeah, I'm gonna get a perfect in math. 7 out of 10 chance you could get it. But the probability of not getting it, what will it be? Remember, it should be equal to 1. Yes, now you know. Denominator is 10. What number would I put on top? 3. Yes, because to make it one whole, the numerator and the denominator should be the same because that's equal to 10 over 10, which is 1. Okay? This is not getting a perfect score. Again, remember, they complement each other. Let's try the following. A bag contains 7 red marbles, 9 blue marbles, and 8 marbles. What is the probability of reaching out in the bag and getting a blue one? Okay, probability of getting a blue is what I want. Okay, so to get a blue, how many blues do I see? Look at the here, it's obviously 9, so 9 goes up over the total. Okay, over the total possible outcome, which is what? 9 over, let's add the 7 plus 9 plus 8. 7 plus 9 plus 8, that's going to be 9 over 16 plus 8 is 24. All right? So the probability of getting a blue, oh, guess what? You can simplify it so it's easily understood. Divide by 3, divide by 3, that's a 3/8, right? So the probability of getting a blue is 3 out of 8. Is that less likely or more likely? It's lower than the 4, right? Lower than half. So you could say less likely. Okay, got it? Next, a single die is rolled one time only. What is the probability of getting a number, a prime number? Okay, let's write down the numbers first. Again, 3, 4, 5, 6. Probability of getting a prime. Oh, you forgot what prime numbers are. But what's at the bottom? Tell me what's at the bottom. Yes, 6, because there are 6 possible outcomes. 1, 2, 3, 4, 5, 6. Now, which are the prime numbers? 2 is a prime number because you can only have 2 times 1, 3 times 1. You're not a prime. You're a prime. Is 1 a prime though? 1 is neither prime nor composite. So how many prime numbers do I see? I see three numbers. So the probability is, lowest terms, 1/2. Probability of getting a prime number is 50-50% chance. Okay? In the middle. Next. A piggy bank contains 10 nickels, 22 dimes, 13 quarters, and 5 half dollars. A coin which is half a dollar or 50 cents. If you shake the piggy bank, and a single coin drops, oh my gosh, what is the probability that the coin is worth at least 10 cents? Oh, I forgot the word at least. At least means the number should be what? Greater than or equal, less than or equal. At least means yes, greater than or equal to 10 cents. Okay, but let's review the money that we have. Okay, so for 5 cents, we have 10 coins, 10 cents, 25 cents, and half a dollar. Now, probability of X greater than or equal to 10 cents. Okay, what are the coins greater than 10 cents? Greater than or equal to. So it could be equal. It could be greater. Is 50 cents greater? Yes, it's also greater. So how many coins are these? 22. So that's 22 plus 13 plus the 5, right? Those are the coins greater than or equal to 10. Over what? The total. What's the total? All of them. 22 plus 13 plus 5 plus another set of 5 cents coins. There you go. All right. So let's add the top. That's going to be 5 plus 5, 10, carry 1 to 40 coins over a total of 50 coins. 40 out of 50 is 4 out of 5. Oh my God, the probability of the coin could be at least 10 cents is 4 out of 5. Very likely, right? Very likely. Because it's greater than half, greater than 50%. Next, if the probability that Julie makes her shot in the basketball game is 0.36, okay, she's a good player. Okay, probability of getting a shot in the basketball is 0.36. Okay, what is the probability that she does not make the shot? Okay, let's see. 0.36 complement, remember complement, plus what number gives me what number? 1 whole. Okay, what number will you add? 1.00 minus 0.36, that becomes 4. 9 minus 3 is 64, so 0.64. This is the answer. Remember, when you add them, it's always equal to 1. Now let's try these ingenuity problems. Jamal knows that it is certain that he will win the election because he's the only person running for treasurer. All right, there's no competition. Which value represents the probability that he will really win? Okay, it's not 0, means he's not winning. Here, there's less likely. This is more likely. Yes, 1 always represents 100%. Good job. Victoria knows that it is impossible to remove a red marble from her bag which has no red marble. The word impossible. See? She wants to reach out in her bag to grab a red marble. Okay? What is the probability that it's going to be a red marble? Can it be 1? No. Can it be more likely, less likely? No. Definitely no way. No way will she get a red marble. Which value cannot represent the probability of an event occurring? It will happen. If it happens, remember our scale is 0 to 1. Okay? So this is still part of that. Yes, it will happen. This is still part of that. Yes. 0.62.5 is 0.62. That is still here. How about 1.1? It goes beyond 1. Can you be beyond certain? No, you can't. So that's the answer. No way can it be 1.1. So sometimes people would say, oh, I'm 120% sure. You don't need to add that 20. 100% sure is already what it takes to be sure. Last problem. Ready? The cooler at a picnic contained 4 apple juice boxes, 8 orange juice box, and 6 fruit punch juice boxes. A juice box is selected. We select just one. What is the probability of the complement? Ooh, of choosing an orange first. Okay, let's do the probability of getting the orange. Okay. The probability of getting an orange is how many? 8. Right. 8 over the, what will I do? Yes, add the total. 4 plus 8 plus 6. So that's going to be 8 over 18. That's the probability of getting an orange. Okay? Some people will make the lowest terms and make it what? Divided by 2, divided by 2, 4 over 9. Are you tempted to choose that? Nuh-uh, because guess what? It's asking for the complement. Okay? So let's write down 4 nines plus what number will give me 1? The complement. Okay? The probability of not choosing the orange. Okay, so what do I write? It's gonna be over 9 again. What will I add to 4 to make it a 9? Yes, 5 nines. So that's the answer. Okay, so that's what we learned about probability today. Remember, guys, results is equal to action plus motivation. Are you certain you understood? Say 1. Yes, 1 means 100%.